Okay, so the four congruencies, what do we got? Side, side, side.
Yes.
Angle, side, angle. HS. And SAS. Okay, side, angle, side. So when we look at these, we need to say what information are we given here, right? And remember, when we do the proof in a two-column proof, right, it's like statement, justification, right? So we're going to make some statement, this is equal to this, we have to give a reason why. And so before we do any of these things, we should come up with, well, we know these two angles are equal, right? That's given. What's the indication with these lines? That these lines are parallel. Okay. So, and then these sides are equal. Okay. So, because we've got parallel lines, what else can we do? And then which of SAS, HS, et cetera, are we going to use? Side, what? Side, angle, side. I do not see another side that is equal, so.
Isn't AE and DC equal?
Nope, they're parallel. They may in fact be equal, but we are not allowed to make that statement because we have no way of knowing. Okay. You see the two lines on B, C, and D, E. Those lines, those say those are the same, right? Those are the same. So the fact that these are parallel means we probably want to do something with parallel lines, right? So I got parallel lines. I've got this angle up here, which is beneath and to the right of the transversal, and I've got this angle here, which is beneath and to the right of. So what kind of angles are these guys? So they're in the same position. What do we call angles that are in the same position? Corresponding. Those are corresponding angles, right? Okay, so we know that those angles are equal. And so what we're going to use is one, we don't necessarily state it all the time, but there's angle, angle, side, right? Angle, angle, side. And the reason that angle, angle, side works is if these angles are equal and these angles are equal, then we know that these two are equal, which really gives us angle, side, angle, right? But we have the special one we call angle, angle, side. It's just really a subspecies, a subset of angle, side, angle. Okay?
How do you know angle A and angle B are equal?
Because they're corresponding angles. Yeah. It's like he got one, and right beside you, he whispered it in. And they are equal, so. By Wednesday, hopefully you'll know these, right? You're going to have to go back through all of the corresponding angles are equal, alternate interior angles are equal, adjacent angles, adjacent interior angles are supplementary, et cetera, right? And look through the proofs and go through. Tomorrow we've got review, right? So you've got a chance tomorrow to do some review. There's mid-chapter review in the book. There's a chapter self-test in the book and a chapter review in the book. Okay, so we are going to use the plan is angle, angle, side. And so we need to show the two angles. So we've got a statement, angle ADE is equal to, so ADE, we're talking about this guy, is equal to DBC. And that is given, right? I mean, if you say, why do you get to say that? Because they're marked as equal angles, so it's given. Bless you.
Thank you.
Side AE is parallel to DC, and that's given. Okay. Since the lines are parallel, we can then make the statement that angle DAE is equal to angle Give me the name. What is it? Just follow the same path in the other triangle. BDC, right? Okay, so make sure you're following the same path in the other triangle, right? So we're going from this single angle up to the double angle out to the side, so from the single angle up to the double angle out to the side, right? You want to name them the same. And what's the reason that those are equal? Ryan? You said it.
Oh, supplementary. Corresponding. I forgot. Shay showed up.
Corresponding angles. Okay, that means we need that statement about those lines being parallel. You can't just say, hey, there's a corresponding angle, without saying, hey, these are parallel lines, so then these are corresponding angles, and then they're equal to each other. And now we've got everything we need, right? We've got angle, we've got angle, angle, side. So now we make the conclusion, therefore, triangle AED, which is what they wanted, is congruent to, they're using 3 lines, we usually use like an equal sign with a little wavy line up top to mean congruent, to triangle DCB. And the reason is angle, angle, side. And when you name them this way, right, we say angle A is the same as angle D, right? They're both marked with the double angles. Angle E is the same as angle C. They're the unmarked angles. Angle D is the same as angle B. They're the ones marked with the single and the cross hatch. That side AE is, is equal to side DC. That side ED is the same as CB. And that side AD is the same as DB. Right? Or side DA is the same as BD. Okay, so when you've named the congruency, then you can say, well, this angle is the same as that angle. This side is the same as this side, and so on. Okay, any questions? So, let's, we don't have any more on there. Given BD is perpendicular to AC, all right, so then we can draw the box in, right? It wasn't there, but we are given that it's perpendicular, so it's a 90-degree angle. We can draw that in. If we're going to make some statement about it being a 90, we're going to say that it was given. And that AD is equal to DC. So we're just going to mark on here that these two guys are the same. Prove that triangle ABC is isosceles. Okay, so what makes it isosceles? What's the condition for being isosceles? 2 equal sides, right? Exactly 2 equal sides. Okay, if we have 3 equal sides, what is it?
Perfect.
Equilateral. Okay, it's equilateral. Okay, so what are we going to use? So remember, think of these as 2 different triangles, right? They are, and there's a 90-degree angle here. So I got a side, I got this angle. What can we say about this side? In this triangle and in this triangle. It's the same, right? Because it's just the one line. Okay, so we've got side, angle, side, right? That's what we're going to use. That's the plan. Okay, so the plan is, I know this side, they told me this was perpendicular, so I've got this angle, and this side is common to both triangles, so it's the same. So the plan is to use side, angle, side. Okay, so plan, right, which means that our last statement is going to be, well, actually we'll say, therefore that they're congruent, and then we'll say that since AB is equal to BC, that it's isosceles, right? So once we prove congruency, then we still have to say, okay, but then these sides are the same, right? The corresponding sides, they correspond to each other in the triangles, not corresponding in terms of parallel lines, but they're the same side. Those sides are congruent, and therefore the triangle is isosceles, right? That's what we're going to end with. A couple lines before that, we're going to say, therefore this triangle is congruent to this triangle by side, angle, side. All right, so what have we got? Well, AD is equal to DC. And that's the other. We've got that BD is perpendicular to AC, and that's given. Which means that we know that angle BDC is equal to angle BDA is equal to 90 degrees, right? I mean, I could have made two statements. I could have said BDC is 90 degrees and BDA is 90 degrees, but I'm just going to go with one line. So BDC is equal to BDA is equal to 90 degrees, and that's just the definition of perpendicular, right?
I like that one.
Okay, so by the definition of perpendicular lines, those angles are 90 degrees. Okay, we've got the side, we've got the angle. Now we need to make the statement about the side. So BD is equal to BD, right? It's a common side. Little 3 hash marks on there, right? I mean, just because if you put the 3 hash marks on there, you can see, okay, I got the side with 2 hash marks, then I got the angle, then I got the side with 3 hash marks. With, yeah, that's my side angle side, right? Side angle side. So therefore, triangle. All right, what are we going to call it? ABD is congruent to triangle. All right, what's the other name? CBD. Yeah, CBD. Reason? Side angle side, right? Side angle side. Okay, we got 4 reasons and 1 sub reason, right? Angle, side angle, angle, side. Okay, so now what do we say? Well, we can say that AB is equal to CB, right? Because they're congruent triangles, so side AB is equal to CB. So AB is equal to CB. The reason is that they are they're congruent. Here, I'll give you the fancy one. CPCTC. Congruent parts of congruent triangles are congruent. Okay, so you could just write in that they're congruent sides. Okay. Let's move that down here. So just say congruent sides. Okay. So sometimes we use this CPCTC, right? Congruent parts of congruent triangles are congruent. Okay. So that applies to angles. You can use that as soon as I've made this statement here, I can say AB is the same as CB. I can say AD is the same as CD. I can BD is the same as BD. Reason CPCTC. I could say that angle A. See, I can refer to angle A here because it's unique, right? There's only one angle A. I can't refer to angle B, right? Hey, where's angle B? Well, it's either here or here. It's the whole thing. Okay. I can refer to angle C. It's unique. I can't refer to angle D. There's kind of 2 of them, right? Or 3. This one, and the whole thing. So we're better off naming the angle. So I could say angle BAD is the same. Start at the middle. BAD is the same as BCD. Okay. And again, that's all CPCTC. Since these 2 sides are equal to each other, then the triangles are isosceles by the definition, right? So therefore, triangle ABC is isosceles. ISOS, missing an S. Isosceles, right? And the reason is definition of isosceles. Okay, so we're saying since this line is the same as this line, we have an isosceles triangles, right? We have two sides equal in the big triangle, right? Now we're talking about the big triangle, ABC. So that whole triangle, these sides are equal, therefore it's an isosceles triangle. Okay, any questions? Next. Given AC is congruent to BC, that SC is congruent to RC, prove triangle ACS, this triangle, is congruent to BCR. Okay, so it's a little tough to kind of mark these, right? That AC is, because, you know, AC is this whole thing, and then SC and RC are these guys. So we won't really mark it, but we'll just have to keep in mind as we decide. You notice the C's are the same, and there is only one angle C here, right? So we have a common angle that we can use. Okay, and then what else? So we've got this side AC is the same as this side BC. We don't really have a triangle ABC. But you had a common angle in the middle, so alright, I think we got it, right? It's going to be side, this angle, and this side, right? Because they gave us this side. Okay. So in triangle ACS, we've got AC, then the angle, then this side. And in triangle BCR, we've got BC, which we're told is the same as AC, right? So we've got this side. These sides are the same. This angle is the same. And then these sides are the same. Right? So it's side, angle, side. So the plan is side, angle, side. So AC is equal to BC, given angle ACB, sorry, ACS, let's go with ACS, is equal to angle BCR, angle BCR. Why are those two angles equal? There's not really two angles, it's one angle, right? There's only one angle there. So it's a common angle, okay? So it's common. Okay, there's only one angle C, really. And then what else? So we got AC, so we need CS or SC. So SC is equal to RC, and that's given. Therefore, triangle ACS congruent to triangle BCR, and the reason is side, angle, side. Now, something you might want to do, because remember I said we can't really mark on this diagram. Everything's kind of on top of each other. But what we could do, right, before we do any of this, we can start out and say, you know what, I'm going to split out triangle ACS. And I'm going to split out CRB. Okay? So one of the tactics in doing this is if things are kind of muddled together in one diagram, right, is to split it out and then say, okay, what did they give me? AC and BC are the same. AC, BC. SC and RC. These two guys are the same. This angle is the same, right? Because it's a common angle, right? And now you can see, oh, yeah, look, it's side angle side, right? By having split the diagram out into two separate triangles, it makes it a lot more obvious what you have to do. Okay. So that's probably a better first step, is to take this diagram, split it out like this, mark the congruent parts, right, that are given, and then you measure, okay, look, I've got side angle side, and then here side angle side. Okay, that make sense? Split it out. Okay, especially when they're saying stuff like this, right? Because you can't mark AC the same, you can't put a line on there and, well, you kind of put two lines there. Yeah, you don't want to do that, right? So you want to do this instead. Given AR, now here the two separate triangles aren't intermingled, right? So we can label on the diagram and it should be fairly obvious. So AR is the same as SR. BR is the same as RT. And prove that AB is the same as ST. Okay, so I'm going to say, I think this angle is the same as this angle, and you could tell me why are those the same?
Because they are
Vertically opposite angles, right? So we don't need parallel lines, we just need two lines that cross, and we know that the vertically opposite angles are. So we've got side angle side, right? Side angle side. That's how we're going to prove this. That's the plan. What I'm going to do once I've proved it by side angle side is then use a little CP/CTC, right? Because what we're supposed to say is these two guys are equal. So we need to prove the triangles are congruent. Once we've said they're congruent, then we can say these two sides are equal to each other. And the reason we'll use is CP/CTC, right? Which you could write in as they're congruent triangles, right? But CP/CTC is so much more cooler. Okay, so where do we start? We just start with basically the given, right? AR is equal to SR, given. That's the side. Now I'm going to make the statement about the angles, right? Because I want sort of side angle side. So angle BRA. What's angle BRA equal to? TRS, right? So we're starting on the side with 3. So B to R is going down the 3 side, so TR. We want TRS. Angle TRS. And the reason is they're vertically opposite. Opposite angles. And then we've got the other sides, right? So we've got AR and SR. So now we've got BR is equal to, I'm going to call it TR. Right. I mean, it doesn't really matter if you call it RT but BR is going from this angle into the middle, and TR is going that same way. So. And that's given. Therefore, triangle, okay, well, we could just go back to this, BRA is congruent to triangle TRS, okay, and the reason is side angle side. I wrote the plan without the plan with side angle side. And then, what do we want? AB. So AB is going from here to here. So we're going the third letter to the first letter, so we're going third letter to first letter, right? And therefore AB is congruent to ST by CPCTC. And CPCTC. Congruent parts of congruent triangles are congruent. Okay. 3 more. Wait. So basically you're going to see a bunch and then you need to do a bunch just to kind of cement, right? Like, okay, what's my plan? How am I going to do this? How am I going to show this? Now, we might be nice to you on the test if I recall, I don't know, Ms. Cormos is making up the test, who knows, but we might give you like a 2-column proof where we kind of fill some stuff in and leave some stuff blank. Right, so that we kind of give you the skeleton of the proof, and we'll make a statement like this. You'll have to say given, or you'll have to say whatever, right? Or we'll give you a statement like CPCTC, and you'll have to say, well, this is the statement I'm making, and the reason is, right? We'll give you the reason or the justification. You give us the statement, or vice versa. Okay, AB is perpendicular to BC. AB is perpendicular. AB is perpendicular to BC. AD is perpendicular to DC. I think I see hypotenuse side. Maybe, I don't know. AB is the same as AD. AB, yes. And here's the hypotenuse, which is a common side, right? Let's mark that one, kind of 3. So if the hypotenuse is common to both triangles, they have an equal side. It's hypotenuse side, right? That's the plan. Plan, HS. What angle? Well, the angle's a 90. That's what makes it hypotenuse, right? So hypotenuse side is just kind of a special case of, well, what? We sort of have side-side angle. It's not really the included angle, but, because it's a right angle triangle with 2 sides the same. So I'd go with, it's really like side, 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 right? Because if that's the hypotenuse and these 2 guys are equal, then these 2 guys have to be equal, right? Because it makes a Pythagorean triple. So, hypotenuse side is really just a special case of side, side, side. But we don't have to go into the whole side, side, side thing. Okay. So let's start off. What do we got? Angle ABC is equal to angle ADC is equal to 90 degrees. Right? That's definition of perpendicular. You could split this out into 2 statements. Right? You could say angle ABC is equal to 90 degrees. Why? It's perpendicular. You could say angle ADC is equal to 90 degrees. Why? Because it's perpendicular. Or we can, kind of save ourselves a line and say that ABC is equal to ADC is equal to 90. Why? They're perpendicular. AC is equal to AC. It's a common side, right? It's the same side. And it's also the hypotenuse, right? And AB is equal to AD, that's given. So triangle ABC is congruent to triangle ADC by hypotenuse side, right? HS. Okay, we good? Laura's good. She's on her phone. So she must be. All right, given AC is perpendicular to AE, so we got 90 there. AC is perpendicular to DC, and B is the midpoint of AC. Which means that those 2 sides will be equal, right? If it's a midpoint, it's splitting it in half, so that AB must be the same as BC. That'd be the definition of a midpoint. We are to prove that angle AEB is congruent to angle, so we are to prove that this angle is the same as this angle, right? That's what we're to prove. And note it's angle, right? It's not prove the two triangles are congruent. So we're gonna, at some point, we're gonna say the two triangles are congruent, and then say, therefore, this is true by CPCTC, right? Okay, so let's not mark that the same. Okay, so how are we gonna do this? Are we gonna use hypotenuse sine? Do we know the hypotenuses are equal? Nope. So we can't use hypotenuse side. So what can we use? We don't have two sides. Do we have another angle that we know is equal?
Yeah.
Which one? These two guys?
Yeah.
Why? Vertical opposite, right? It gives us angle, side, angle, right? Boom, angle, side, angle. So the plan is angle, side, angle, prove the congruency, and then lastly, make that statement, right? Don't assume that this says triangle, right? I mean, triangle would be an actual, triangle. So make sure you're reading the question carefully so you don't just sort of end with, therefore the triangles are congruent and that's what you want me to prove. And no, you needed to go one step further, right? You lose like a half mark. You wouldn't quite be all the way there. Okay, angle, side, angle. So which angle shall we start with? Start with the 90s. Angle, EAB. Angle EAB is equal to angle DCB is equal to 90 degrees, and the reason is definition of perpendicular. I can't write. Definition. Okay, so we got the two perpendicular sides. Gives us the angle. Now we want to mention the side. So AB is the same as CB, and the reason is? Not quite.
Because they have the common line.
So the reason we're going to use?
That thing, yeah.
So the definition of a midpoint, right? Definition of midpoint. So it's not really given. I mean, but it follows from something that is given. They told us it was a midpoint, so we know it split them into two equal pieces. All right, so we got angle, we got side. Now we need the angle. So what are we going to call it? Angle, what? ABE? Actually, you know what? Let's go, yeah, ABE, sure. ABE is equal to angle CBD, and the reason is? Vertically opposite. Vertically opposite angles. Therefore what? Triangle. You know what? If we name the triangles this, right? AEB and CDB, it's going to fall a little quicker than those angles, right? So therefore, triangle AEB is congruent to triangle CDB. And what was the reason? Angle, side, angle. Let's think of aspirin, ASA. And now what's the last statement we're going to make? Angle AEB is congruent to angle CDB, and the reason is CPCTC. Come on. How could you not know CPCTC? You could just say, just give me some like they're congruent angles, right? I mean, they're since the triangles are yeah, but CPCTC. Okay. Ready? What do we got? One more? All right, let's do it. Given ABC is isosceles. So if it's isosceles, then these two sides are going to be the same, right? And D is the midpoint of AC. D is the midpoint. So we know that those two sides are the same. We are to prove that, this is a little weird, because I think we gotta change this to triangle here, right? You're gonna have to add another. We can't prove that triangle is congruent to angle, right? So let's prove that triangle ABD is congruent to triangle ADC. Side angle side, right? How do we know these two angles are equal? It's an isosceles triangle. So these two sides are the same, and these two angles are the same. Side angle side. Three statements, done.
Eventually said that. I've just been here a while.
Yeah, been here a little bit longer. Okay, so we're going to go with side angle side. So AC is equal to AB. Definition of isosceles. Angle ABC is equal to angle ACB. Definition of isosceles. The other sides, BD is equal to CD. Midpoint, definition of midpoint. Of course, we also could have done side, 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 right? Because we got a common side. So there's more than one way to do this, right? We got side angle side because of isosceles. We've got that. We've got side, 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 right? And again, so two sides are equal. We'd say AC is equal to AB. Definition of isosceles. BD is equal to CD. Definition of midpoint. AD is equal to AD, common side, and then you can use side, 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 right? Or here, you know, we've got this. You could say, or, you know, AD is equal to AD, common side. So one or the other. Therefore, triangle ABD is congruent to triangle ADC, and the reason is side angle side or side side side. Okay. So you could have proved it either way. Question for you are on page 112, 1 to 7, 9, 10, 12, 17, and 19. Responsibilities for you are basically to be able to duplicate any of this stuff on a test. Likely, we'll give you one or two where we've at least filled in partial bits for you so that you'll know what a two-column proof looks like, and when you have to do one fully on your own, you'd be able to look back and say, what were they doing here, right? Like which reasons, and you know, remember the triangle congruencies. Angle side, angle side, angle side, 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 hypotenuse side, angle, angle side. Know all of your parallel lines, right? Corresponding angles, vertically opposite angles. Well, you don't even need parallel lines for vertically opposite. But corresponding angles, alternate interior angles, alternate exterior angles, etc. Right? And just all the various reasons.
Can you go back to this example?